Hello, I'm Paul Beckwith. I usually teach climatology, meteorology, and oceanography at the University of Ottawa and first year physical geography at Carleton. This term, thus far, and next term, I don't have any teaching contracts. So on the plus side, I can make a lot more videos, but on the downside, my income is exclusively relying on PayPal donations. So if you enjoy this video and you watch some of my numerous videos, I have over hundreds of videos, then please consider kicking a couple dollars to my website. So I asked this question a few days ago. I'm going to kill the light illuminating me. Get rid of the glare on the screen. So will Irma be a superstorm like Harvey? Two video tutorial. This was posted on September 5th. This is me here after I saw the latest forecast for Hurricane Irma. These videos, by the way, these still action shots are very easy to do with digital cameras. Your phone, all you need to do is go to the slow-mo film it, and then just select frames from it to post. Makes great pictures. So the answer to this question is yes. I think that's pretty clear to everybody now. So let's move on. Okay, so Irma is a beast. Okay, so the best way to follow Irma is real time, basically, get the very latest, is to get a Twitter account. Okay, follow me, at Paul H. Beckwith, follow, and learn how to use hashtags. So you can search for hashtags, so hashtag Irma, hashtag Hurricane Irma, all of those things people post to, they use a hashtag, so it's like a mailbox for all of this stuff to go to. So you can get real-time detailed information on what's going on. Of course, this is changing. So this video is basically to give you the tools to track and see what's going on and get a very accurate picture of what the hurricane is doing. So this is just a radar image repeating, for example, the latest forecast. Okay, this is the GFS, which is the National Weather Service, National Hurricane Center. This is a U.S. forecast. So they gave a cone here. The storm is here at 5 p.m. Thursday, and here's where it's moving, and it's turning, and it's looking like a direct hit on Florida at the moment. Now, this model has consistently been reading a little bit on the high side, whereas the European model has been more accurate, and I'll show you that in a minute. This is showing the relative size of the storm relative to the forecast cone, so high winds can go outside of this cone. So as Irma negotiates the ocean towards Florida, there's a couple of things that can happen. First of all, the water is extremely warm in this region, so that will allow Irma to gain strength. She's a Category 5. If the winds are over 155 miles an hour, it's a Category 5. Now, Irma was about 185 miles per hour for over a day, a long duration, set a record for that. Tapered back a little bit, but the water is very warm, so that will cause the winds to increase. It will extract more energy from the warm water. What will possibly weaken the storm is the islands, the hills, like the parts where it goes over land, or where part of the storm goes over land, will weaken the storm. We've got some mountainous areas in Cuba, so if it veers a bit south, it will be weakened by that. Also, if it's moving very slowly, and it churns up water, uses up all the warm water on the surface and churns up some cold water, that could also temper the increase of energy in the storm. Except underneath the water, going deep down, is very, very warm water. This is a problem. Okay, so there's, this is a high-resolution regional model showing where the low is going, and it's showing 873 millibar, because the water, or 893, that's a big difference. 893, sorry, because the water is so warm, the low is getting lower, the winds get stronger. Okay, this is a comparison of the last two U.S. forecasts, National Hurricane Center forecasts. So the previous one was up here, and then the 2 o'clock, and then the 5 o'clock p.m. one, 3 hours later, is shifting. So it's showing a westward shift, which aligns more with what the European models are showing. Okay, this is a European model. The ECMWF is a European model. It's showing the wind gust swath. going, the type of winds that will be expected going over Florida. So we've got areas here which are, you know, 100, this is in knots actually, nautical miles an hour. You need to multiply by 1.15 to convert to miles per hour. So, you know, this is showing, this is the latest European model, has it going straight up here, and the winds are stronger on the right side than on the left side, and I'll show you why. So this is just my Twitter feed. So like I say, you know, more models and all kinds of cones and stuff. Now you've seen a lot of this stuff by now. Now hashtags, okay? If you do a search for hashtag Irma, then you get all of the posts where people have put Irma in the tweet, okay? So you can get all kinds of posts and details. You know, for an example, also, for example, if you know about the little island, part of Antigua, Barbuda Island, 1,800 people, 95% of the island was trashed. It was in the eye of Irma. Basically huge storm surge, most of the island is low-lying, you know, very few casualties, fortunately. Richard Branson has an island in the British Virgin Islands, and that island had a direct hit. It was also in the eye with most of his properties. He owns the island. Were destroyed, and he and other people were holed up in a concrete wine cellar. This is hurricane force gust winds, and you can see all kinds of different stuff in here. So this is the European model again from 12Z, which is noon, 12 Zulu. This is the water temperature. Look how warm the water is as you go up. Extremely warm waters here. Okay, approaching 31, 32 degrees here. Those will only intensify the storm, as I pointed out earlier. Okay, so let's move on. So basically, there's a couple things I wanted to point out on my Facebook site. Here's a comparison between the European model and the GFS model. Okay, that's one of the things I want to point out. This is, you know, talking about storm surge. I also want to point out about some of the things on Florida that are very grave targets for this storm. Okay, so this was a tweet showing maps, two maps comparing the GFS model, which is the US model, with the European model. The track of the storm thus far has been the X's. Okay, that's the path that has been realized, the actual path. Now, at various points along the path, forecasts were made on the track. So the GFS model, the US model, showed the track coming here and it was lower, showed the track going up here. All the blue lines of the forecast are above the actual track. Okay, so there's a clear bias in this model to the north side, or after it turns to the east. Okay, the ECMWF model is the blue lines, and they line up extremely well with the track, almost exactly on track. So this is a model that is key, and as time progresses and more data comes out, more models come out, the GFS, I think they probably tweak it and tune it and recognize the bias and maybe come back onto the track. Okay, so that's a key point. Another key point is, you know, let's look at Florida. So if you have Google Earth on your computer, or if you don't have it, install it. I think it's free. Okay, Google Earth, I think there's a Google Earth Pro you have to pay a couple bucks for, I think. I'm not sure, it might be free now while this storm is going on. So you can zoom into Florida and you can look at different things. So here we go, zooming in, you get a good layout of where things are. So if the storm is coming right up here, you know, then you can see, you know, where things are really going to take a hit. The other thing is it gives the elevation, okay? So you can get the elevation at various points, okay, -2 meters. This is sea level, right? And if you go on the land, it's 3 meters, okay? So you go way over here, it's only 3 meters. This is 10 feet above sea level. If the storm surge is 20 feet, plus if the waves are 20 feet high, then this is all going to be inundated with ocean water, unfortunately, from the storm surge. The storm surge will be greatest in the right-hand quadrant, right front quadrant of the storm. So if the storm comes right up here, this is the eye wall here, the right quadrant is where the storm surge will be greatest. So this storm can possibly rewrite the coastline and it's affecting millions of people and cost, who knows what, hundreds and hundreds of billions of dollars, making even perhaps, Hurricane Harvey, which caused almost 200 billion, a smaller storm. Okay, so there's lots of stuff you can get. Like I said, the elevation is a very useful key. I mean, this is in the bay. This is the elevation. Okay, 0 meters, 0 meter. I mean, this is the Everglades and stuff, right? So, even up here, 5 meters, okay? You go up a little bit, but you go inland here, it's only 5 meters. That's only 5 meters. I think you can click on this and change the units to feet. But, 5 meters is only 15, 16 feet. So 20-foot storm surge, it could inundate this whole thing in the worst case. Okay, so what do we have? Well, nuclear power plants in Florida. Hope they're prepared. This map here on Twitter, I have on Twitter, it shows the location. So Turkey Point is the most exposed. There's, FP&L Martin, St. Lucie Nuclear Power Plant. Okay, these ones here will bear higher winds than these ones here if the track of the storm comes straight up there. So why is that? Okay, so let's say a storm is going, forget the units, let's say the storm is going 50 kilometers an hour, that's about 30 miles an hour or so this way. Okay, so this storm is going, so Irma is going about 20 miles an hour this way. The circular winds, okay, let's say they're 175 kilometers an hour here in this example. Because the circulation is this way, the wind speed here will be 175 plus 50, 225 kilometers an hour. The wind speed over here will be 175 minus 50 or 125. Huge difference, right? Damage scales is a velocity cubed, I believe. The power dissipated goes as velocity cubed. So this is a huge difference. So here's a different example. So storm's going 100, rotation 100 miles an hour, 20 mile an hour forward speed. The winds here will be 120, here will be 80. So in our case with Irma, we've got 20 this way. Let's say it hits about 180. Then the winds on this side will be 200 miles an hour, which is 180 plus 20. The winds on this side will be 180 minus 20, or 160 miles an hour. A huge difference, much more damage on this side. Okay, this is the cross-section of a typical hurricane. So those bands that you see on radar are here. Where the clouds are, there's rain. Okay, where the clouds are, there's convective uplift. So moist air, the water's very warm. There's lots of evaporation. The water vapor rises, forms the clouds in these bands. This is where the rainfall is, of course, under the clouds. And then the air is descending in between them. The air is descending, so all the water is taken out of it. There's very dry air here, so you get these bands. The surface air pressure is going down like this. So right now it's about 920 millibar. The background will be about 1,000 or slightly over 1,000. And this can go to 893, the model showed, off Florida. The surface wind speed is here. In the eye wall, it's maximum. Maximum. The forward velocity is not added. So you need to add 20 to this side, bringing it up, minus 20 from that side, bringing it down, and you get a skewed distribution. Okay? Climate reanalyzer, remember you can look at the sea surface temperature here, very, very warm water. Earth null school. Here's our storms right here. And I want to show you quickly, if you click here, okay, let's click here and bring it down. So there's our storms. And this relies on GFS, which is the US model data. So click here to advance a day forecast. Okay, you can see the storm. The storm moves forward. My screen is locking. This goes through a day forward. This is 3 hours. You can go about 5 days ahead, and you can track this cone right into Florida. And I'm not sure why my computer froze, so I can't. You'll have to try that yourself. Just Google Earth Null School and try that.